Hello, my Calc 2 students. Today we talk about integral test and P series, and all is section 9.3. 9.3. Oops. I hope it's work. And we start with some theorem. Let's make our life much easier. Theorem tell us if function f is positive, continuous, and decreasing function for x greater than 1, this means if function f positive, continuous, and decreasing, okay, here I use this phone, for x greatest or equal 1, and n terms in your infinity series, its value, your function f for point n, then infinity series with this terms and improper integral from 1 to infinity your function fx dx, either both converges or either both diverge. This means both converge or both diverge. Prove this theorem you have in the yearbook, and now we're looking how we can use this theorem. Let's go, we have example 1. We have series where is n over n squared plus 1, whereas n change from 1 to infinity. This means our function fx will be x over x squared plus 1. And we need checking what happened with integral x over x squared plus 1 dx, whereas x changing from 1 to infinity. Well, I think the easy way here is use substitution. This means x squared plus 1, let's go, it's t, 2x dx, it will be dt, and your integral now is 1/2 integral dt over t, whereas t changing from plugging x equal 1, you have 1 plus 1, this means 2, until infinity. Okay, we can continue solving this integral, but right now I remember you last example when I show you when we study improper integral. This last example tell us if you have integral from 1 to infinity dx over x to the power p, it will be convergence if p greatest than 1 and diverges if p less or equal 1. You see, I'm not write exactly what number is if it converges, and you have, because it's from 1. But we not important for us integral start with 1 or 2 or any final numbers. Its important part here is infinity. This means now what is power t? Is 1. If power is 1, this means it diverges. If you remember this example, you don't need solving. You need only remember it tell because what is happening. Okay, doing one more example. Let's go here is example B. Series is 1 over n square plus 1. N start with 1 to infinity. And here as function is will be 1 over x squared plus 1. Build this function is very simple. When you have n, plug in x and you don't make mistake. Okay, what we have? Integral from 1 to infinity dx over x squared plus 1. But this is stable integral is exactly arctangent. Okay, doing step by step, this means I need to write limit integral from 1 to b dx over x squared plus 1, whereas b approach to infinity. And here I have limit b approach to infinity arc tangent b minus arc tangent 1. Okay. Arctangent, limit arctangent b if b approach to infinity is pi over 2. This means here I have pi over 2 minus value arctangent 1 is pi over 4. It will be pi over 4. Integral is convergence. This means our series converges. Okay, we have one more theorem. First definition. This kind of series, 1 over n to the power p, whereas n change from 1 to infinity, we call p series. And we have some theorem that tell us P series converges for p greater than 1 and diverges, diverges for p lower than 1. This is coming exactly for integral test and example what I showed you before. Okay, now we can use this fact and see a lot of examples. For example, what happened if I have 1 over n to the pi power, whereas n change from 1 to infinity? This is p series, right? And p equal pi, who is 3.14 and continue, but is important is greater than 1. This means converges. I think now we're ready for solving a couple of examples from your book. First, question number 6. Here you have series and e exponent minus n to the halves and change with 1 to infinity. Well, I think we have exactly integral test here. Our function fx will be x e to the negative x half, and we need to evaluate integral from 1 to infinity x e to the negative x half dx. Okay, I don't write limit now because maybe I'm doing separately counting this integral, because here we have polynomial function times exponential. It means use integration by part. Okay, what is will be x e to the negative x half dx. Here is x is u e to the negative x half dx. It's dv. Du will be dx. It's great. V, it will be negative 2 e to the negative x halves power. Okay, this means uv minus 2x e to the negative x half minus v du, but use minus we have, this means plus 2 integral e to the negative x half dx. Okay, finally we have negative 2x e to the negative x half minus 4 e to the negative x half. Okay, maybe I'm right. It will be minus 2x minus 4 divided by e to the x half. Now we go back with our improper integral, and our integral is equal limit b approach to infinity from 1 to b x e to the negative x half dx. And now we can plug in, and we have limit b approach to infinity minus 2b minus 4 over e to the half b power, and minus what happened if you plug in negative 1, it will be 6 over e to the 1 half, and this is will be plus. Okay, second term is not depend b. This means here we have we only working with this part, and what I have here, a limit minus 2b minus 4 e to the b half b approach to infinity and plus 6 over square root of e. Great, but how we can find this limit? I think it's L'Hopital rule help us. You see, for solving one problem, how much knowledge we use. Okay, limit b approach to infinity. Take a derivative as numerical, it will be minus 2. Take a derivative, you have 1 half e to the half of b. B approach to infinity, your denominator approach to 0. This means here you have 0 plus 6 over square root of e, and you have 6 over square root of e. Integral is converges, this means series converges. Okay, see more example. Example number 16. Today I try to show you more examples than usually, and you can see what we have, what has happened. Okay, number 16. Here we have series 1 over n square root natural log n, and start with 2 to infinity. Okay, our function fx is 1 over x square root ln x. Try found integral here. What we have, integral from 2 to infinity 1 over x square root ln x dx. Okay, ln x we substitute with c. Then dx over x, it will be dt. And our integral is, we can rewrite like 1 over t to the 1/2 power and integral from ln2 to infinity. Remember how we know about convergence of this integral. P here is equal 1/2 less than 1, diverges. We don't need counting, we only can write right now. Okay, diverges, this means series diverges too. Diverges. Okay. I think it's one more example for integral test. Number 22. Doing here. What we have? Series n over n fourths plus 2n squared plus 1. And start with 1 to infinity. fx, it will be x over x to the fourth plus 2x squared plus 1. This means our integral is from 1 to infinity x dx. Here I can rewrite this like x squared plus 1 squared. I think we're doing substitution. X squared plus 1 is like c. X twice x dx, it will be dt. And my integral now, it will be integral from 1 over t squared dt here. And if x is plugging 1, it will be 2 here to infinity. Okay, this is p equal 2 greater than 1. This means converges. And our series converges. Okay, doing a couple of examples for p series. Number 34. Number 34. Here you have this kind of series. 3 over n to the power 5/3 and start with 1 to infinity. Here 3 we can take it out and we have 1 over n power 5/3 and start with 1 to infinity. This is p series. And p equal 5/3 greater than 1 converges. Number 36. What we have here? We have example 1 plus 1 over cube root from 4 plus 1 over cube root from 9 plus and continue. Looks like we have series when you have 1 over cube root from n squared. Or is n from 1 to infinity. It means your p series 1 over n power 2/3. This means p series and p equal 2/3 less than 1 diverges. Okay, see more example. This is example 50. We have series when we have, okay, n 1 plus n square power p, and start with 1 to infinity, and question for which p this series is converges and for which p series is diverges. Okay, fx function here, x 1 plus x squared power, and now we're plugging in the integral from 1 to infinity x 1 plus x squared power p dx. Well, practically we're doing substitution. What we have here, we have 1 plus x squared, let's go it's t, then it's 2x dx, it will be dt, and our integral now is equal t to the power p, 1 half here, and lower limit is 2, upper limit is still infinity dt. Okay, this is improper integral. This means we write limit 1 half, we can write there, it's no problem. B approach to infinity, integral from 2 to b t to the power p up dt equal 1 half. And this is only power integral, it's found, no problem. This means I found and plug in same time. Limit b approach to infinity, I have b to the power p plus 1 over p plus 1 minus 2 to the power p plus 1 over p plus 1. Problem only with first fraction. Okay. If b approach to infinity, okay, if p plus 1 positive power, b stay for this power in numerical. This means you have this fraction, first fraction, approach to infinity. Okay. And integral is diverges. If p plus 1 negative, your integral is converges. Okay, and we're solving. This means if p less than negative 1 converges, if p greater than negative 1 is diverges. If p exactly equal negative 1 is still diverges, because then you have logarithmic function there and it's diverges. This means here we can plug in there and not solving separately. Okay. That's it for today. If you have any question, prepare for our office time. Great.